What's up everyone? Today I want to showcase a simple setup inside Houdini that uses my geometry along the curve node to create procedural buildings. The node was not specifically designed for the building creation, but the most basic function of the node is that we can instantiate geometry along the curve. And that means that we can adopt this node for the creation of the procedural buildings. So during the creation of this setup, I identify multiple places where the node can be updated to make this kind of workflow more straightforward. So in the future updates, I will definitely include new features and updates for the node, for geometry along the curve node, that's going to basically facilitate this kind of a workflow for the creation of the buildings a little bit simpler. But as of update 1.2, there's really nothing that stops you for creating your own buildings. It just needs a little bit more of a setup. So I created this setup to showcase ability and kind of places where the node can be improved. I'm also going to talk about in this video. But basically this file is going to be included in your download for the geometry along the curve node so that you can explore the setup and create your own buildings. And to showcase the biggest benefit of creating a building like this is that it's fully procedural. So let's say I want to change the shape of this building. Let's go to the curve that drives the shape of the building. You can see basically the building follows this shape. Let's say I want this corner to be more of a 90-degree corner. The building is going to be automatically changing these pieces that's going to fit this building like this. And also the floor geometry is a custom implementation of this of the basic custom implementation because our floors are also dynamic, so we have to make some cutouts for it. But at the most basic level, our building is completely procedural. We can also change the number of floors and the cutouts, how they look like, but that's going to be a little bit later. And if you want multiple buildings, you can easily do that just by drawing out another curve. Maybe like this. You see, we have our new building that's also driven by the same network. So let's go ahead and try to go through this network and show you how to create your own procedure building. So the first of all, you're going to need your geometry pieces that's going to be instantiated. So the pieces that are actually that makes up this geometry, this building is inside the building object node, and in here I'm basically creating these kind of angled curves that are being extruded inside this network. So I have 3 collections of geometries, basically the first floor, the second, which is basically the universal floor after the first one. So the first one is going to be a little bit bigger because we're going to have also the entries for it, and the rest of them are basically the same, just simple cutouts, a little bit shorter. So these are 5 meters, and these are 3.5. And also we have our trim for the building for the top of the building. And how it is created is actually very simple. We basically just go ahead and take our curves, and then we just extrude them. Basically, for each angle that we have, we go ahead and extrude our geometry pieces, and this is basically our corners. It's very straightforward. I'm not going to talk about too much, but at the end of the day, we have our corners like this, and they have been assigned angle value. So this is basically if the curve is 90 degrees, if the building needs a 90-degree angle for the corner, it's going to pick this corner. And I have created actually quite a big range of pieces of the corner pieces, which basically with a 15-degree increments. So that's a pretty good variety for the corners so that you can create a bunch of different buildings. And to get our negative angles, we just go ahead and mirror our geometry from here. Basically, we split our geometry that between the angles and straight pieces, and then all the angle pieces, we just go ahead and just mirror it. And after that, we just merge them together and set our attributes that are attribute values that are dependent on the angle value. And then we also use the geometry collection piece node to set only since all of these attributes that are necessary for the geometry along the curve node has been set up inside this network, we do not need to set all of these attributes inside here. The only thing that we need to do is mark this geometry as a corner attribute. as a corner pieces, and that's it. We can uncheck all of the rest of them to make sure that we do not overwrite the values that already set up from this network. And inside here, we just go ahead and take some of these pieces and we boolean out for windows and apply and give some unique names for them. So that's very straightforward. And again, the only thing that geometry collection piece node does is that we mark them as straight pieces, because all the attributes that are necessary for the work inside the Houdini are set up in this network. And again, I talk about all of this in my previous videos. This is just to very quickly go through this network. And we just repeat this again 2 times with the rest of the geometry. Now that we basically just merge all this geometry together to give it a little bit more of a to differentiate, to see the different seams between the modules. I just went ahead and beveled all the geometry pieces, and also I marked the bottom of this geometry as a bottom group, because we're going to use this to get our floors, to kind of get the outline of the floors. Apply some normals. And now the important part is that we want to go ahead and use our geometry collection IO node to save this as a collection of nodes. So what I'm doing it, since the geometry collection IO node requires a primitive attribute to differentiate between different pieces, we go ahead and use the pattern name attribute. We promote it to the primitive and rename to the piece attribute, and make sure that we're also making sure that we do not delete the original attribute value, because it is necessary for us to use in the geometry along the curve node. And since also we're going to use this geometry inside Unreal Engine, I went ahead and set up all the Unreal Engine attributes. And the only thing that we need to do is go ahead and save our collection. In this case, I'm again using the heap geo. I'm saving my collection as building A. And in this case, I'm not promoting any attributes, just a simple geometry. And you can see we have a bunch of geometry pieces. All of the geometry pieces are going to be inside the collection. And to see the saved collection, it will look something like this. Geometry pieces and the JSON file that references this geometry on disk. And now that we have saved our collection, we can go ahead and load it up from disk using another geometry collection IO node. In this case, I'm in the load mode, and I'm pointing to the JSON file that stores the paths to the saved geometry. And I am also transferring a bunch of attributes from the geometry to make sure that I actually importing the packed disk geometry. But since I still need some attributes that I have set up on the actual geometry for the geometry along the curve node, I just go ahead and promote them on my packed disk primitive geometry. So this is going to make the whole process a lot faster without moving all the vertices around. And now we have to go ahead and split our geometry by floors. So I'm using the name attribute to use an F1, F2, and also a trim naming scheme that I have created for the different parts of the building to separate them, because we're going to use each one of these different geometry collection sub-collections, I guess you would say, to create these kind of like a single floor for each geometry, for each floor of this building. So in this case, I'm using the 3 different geometry along the curve nodes to describe the possible second floor geometry patterns. So this is where the first improvement might be useful, to maybe kind of like give ability for the node to create bunch of different floors automatically without using multiple geometry pieces. That's one thing that I wanted to maybe improve in the next update. Another thing is that we have a little limited way that we can basically evaluate these geometry pieces, basically the how we can choose which geometry is being copied along the straight pieces. In this case, for the first piece, for the first floor, I'm using basically a randomization like this. I'm basically specifying which piece to copy along here, and then just randomly. So we also have a cycle, and we have a pattern or a cycle. So these are all the options that you have for right now. And in the future, there might be more robust way for us to scatter more more specific ways of geometry. And the another improvement that I think I can make is ability to override the unique, basically the single piece for the patterns. This is because right now I do not want to randomly add some entries for this for the first floor. So I could basically say, okay, I also want to randomly add some entries. You can see in this case, it's going to just go ahead and start randomly adding entry geometry pieces. And there's maybe too much entries, basically the entries for in the building. So let me go ahead and remove this entry module. So the ability in the future should include ability to override single module to place in basically to place a new one in basically replace the specific module with the new one with the user specific module. And but since I do not have this ability in 1.2, I went ahead and basically I went ahead and took all the modules and I just split it by the names that I know that are basically I just went ahead and split the straight modules and checked for the right sides of the module, because right now we are actually having two sides of the modules, and that obviously we want to check, make sure that our door module, which is the big one, is going to be only the big straight modules are going to be selected as a possibility for replacement for the doors. So I do this inside this network, and I just override that point with our entry module, which is like this one. So it's pretty straightforward, but again, not the most intuitive thing to do. So that's definitely one thing to do in the future for this node. Since I wanted to get this geometry also inside Unreal Engine as a point cloud, I needed to get some information on my points from the output 2, which is basically the point cloud information for this building. I needed to get some information from the copied geometry inside here. And by default, the geometry along the curve node does not give you this ability to carry some custom information on your instance points from the second output node. So the information that I wanted to bring from this geometry is the height of this module of this geometry of the copy geometry. So once again, this subnetwork that is connected to each one of these are the transferring of the height attribute to the instance points of the geometry. So that's another kind of workaround that was needed to make this setup work for the Unreal Engine inside Unreal Engine. But basically, after that, we go ahead and give each copy geometry its own unique name. Basically, we pack it and give it a unique name. In this case, I'm just using the F0, F1, 0, and then F2 have three different modules with a different end number. And then the trim, and the last one is trim. We just go ahead and merge it together. And the most custom part of this implementation is this wrangle node that basically gives us ability to specify patterns. So let me go ahead and take a look at the end result. Let's go to this one. Let's say I want to only delete this one. So you can see, remember that we named our geometry inside. We gave our unique names for each one of these, called the names, and we basically sample it. Basically, we can then set these values inside here. So let's say I want my floor 1 first, then F2 0 modules like a 2 time, and then F2 and F2. Let's actually say F like this. So this is the modules that I want, and at the end of it I want my big trim. So this is the kind of how the geometry is being created right now. So it's a little bit more manual way of creating a building. So in the future there should be a better way to create these buildings more procedurally and with less manual input of the patterns, but this does give ability to kind of work with it right now with this implementation. And how it is powered is actually pretty cool. If you go to the parameter, you go to the pattern, which basically is per parameter, and if you go to the menu, so the menu is actually the Python script that appends the selection from the drop-down menu to the string that is already set inside this parameter. So this is how we actually can go ahead and say create this kind of a building when we basically do not replace the string that has already been set inside this parameter. So if you are interested in the Python how it's made, go ahead and check this Python menu script. But let's say I'm happy with this pattern and the actual wrangle node inside here. We sample from this pattern, we split it by the white space, and then we just iterate through it. We sample its height, and we apply this height to the outside of the loop. So that means that the next time the geometry is going to be copied, the height is going to be changed when we copy our next module. So this is how we get the correct heights for each one of these copied geometry pieces. So it's very straightforward. And then we just go ahead and, since we are setting on our points the name attribute, we just go ahead and use the copy to points node to copy these modules inside here. And from here, use the copy node and say, okay, name. And then what you can do is go ahead and unpack it. The geometry, now we have our point cloud that is ready for instantiation inside Unreal Engine. Almost, I guess I would say, because we do not have our Unreal instance attribute. So what we do, we iterate through each one of these point clouds using the pattern name, and then we get our collection, our input collection. Then we just blast everything except for that's loops for the specific pieces. For that specific pieces, a pattern name. So in this case, you can see that in this case we have blasted, and we just go ahead and transfer the Unreal instance attribute to these points. And with this transfer of the Unreal instance attribute to these points, this geometry is ready to be instantiated inside Unreal Engine or Houdini. The only thing that is missing is our floor geometry. So let's go ahead and take a look at how we create our floor geometry. So the floor geometry can't really be added to the general collection of all the pieces of the module building that we have saved on disk, because the floor is dependent on the input curve. And since the tool going to snap the input curve to their angles, we also can't really use the input curve to create our floor. So in the future updates, the node should also provide you with the snapped curve, like a third output of the node should be like a snapped curve, basically the modified input curve. So that would be a good starting point for the floor geometry, for creation of the floor geometry. But right now we do not have that. What I am doing it a little bit differently. I am taking this geometry, I am unpacking it, I am blasting the bottom group that I have created, and I'm using the extract silhouette node from the labs nodes, and basically getting this kind of outline. And then I'm doing some modification, and I am matching it to the center of the grid, setting up all the Unreal instance attributes, and saving the geometry on disk. And then I am packing the geometry and using the same geometry to be copied on our points, on our basically our points, on our these points, basically the instance points of each floor, like this. Then we do basically apply some other attributes, then we extract our points, and we use the match size to match it to our grid inside here. Basically to match it right at the middle, and we basically have our floor geometry also now basically added to the point cloud. And now really the only thing that we need to do is go ahead and save our point cloud or instantiate our geometry with basically our collection and our floor geometry as inside here. We can use as a pattern name or as a point cloud, save it on disk. So let's go ahead inside Unreal Engine and see how it is set up inside there. Inside Unreal Engine, we want to go ahead and import our point cloud. But before that, we want to create our geometry that we have saved from our collection, and also we have also our floor geometry, our single floor geometry piece. So inside Unreal Engine, what you need to do is go ahead and put down the import geometry in Unreal node that comes with the download. And all you have to do is, since I have talked about this node many times, you just want to go ahead and say, go ahead and point to the point to this folder where you saved all your geometry pieces. And since we have set up our Unreal attributes, all the geometry pieces should be copied in the folder that you have specified where to cook it, and this should be inside here. All of our module pieces has been cooked and now can be instantiated. The only thing that we need to do is also import our floor geometry. And to get our floor geometry, we just want to go ahead and put down another import geometry inside Unreal Engine node, and instead of the PDG type, put it in the type of the single node and just point to the floor geometry that you want to cook out. And basically then just go ahead and bake it out. So this is my previous geometry shape of the building. Let's go ahead and update it. So the updating, let's go ahead and say, let's reload my geometry on disk for the floors and also for the point cloud. Inside Unreal Engine, let's go ahead and update our floor import. Let me go ahead and recook this floor. And you can go ahead and you can see the input geometry. You can see that the outputs are the SM floor 0. You can just press on bake. And now we have floor has been updated. You can see now it's 90-degree angle. And the only thing that we have to do is go ahead and re-import our point cloud. So for the point cloud import, I'm using the BGO import node, which is basically comes with the Houdini by default. All we have to do is go ahead and point to the point cloud we have saved, and we can go ahead and say recook. You can see we have now recooked the point cloud that we have saved, and our geometry, our building has now been updated. And that's basically it. And all of these references are for the geometry that we have already cooked out from the bakes from the other Houdini nodes. This is kind of ideal way for us to get this building inside Unreal Engine because we are referencing the already cooked assets inside the content browser. So that's basically it for this video. I really quickly wanted to showcase this kind of workflow, and I'm going to add this heap file inside as one of the showcase heap files. So I'm not going to update the Houdini, so the Unreal file. So the Unreal file is going to stay the same with the fence example because I mean, there's nothing really special happening inside here. We are just importing the point cloud. So that's basically it for this video. I really hope you found this tutorial useful, and in the future there's definitely better way of creating these kind of procedural buildings inside Houdini, but I just wanted to showcase you this way of creating it for now. Okay, that's it for this video, and see you next time.